We're going to start our next section, which is 11.4, which is about the cross product of two vectors in space. So I will mention we have the dot product, but remember when we take the dot product of two vectors, we don't get back a vector, it's a scalar. But when we take the cross product of two vectors, we get a vector. So let me start by defining what the cross product is. So I need two vectors. Let's say I have u is going to be the vector u1, u2, u3, and the vector v is going to be the vector v1, v2, v3. And then I'll say the cross product of u and v is the vector u cross v. It'll be u2 v3 minus u3 v2I minus u1 v3 minus u3 v1j plus u1 v2 minus u2 v1k. Now I will say that this really long formula here is kind of hard to remember, so I want to give you another way of thinking about this cross product, and it's through something called the determinant form. So if you're familiar with the determinant of a 3x3 matrix, that's exactly what we're going to do here. But if you're not familiar, that's okay. We'll walk through it. So when you take u cross v, you're taking the determinant. So you're going to take in the first row and write I, j, k. And then you're going to copy the first vector here down in the second row. So u1, u2, u3, and then copy this third vector into this third row. So it'll be v1, v2, and v3. And then what you're going to do is you're going to focus in on this first row here. So I'm just going to circle it in blue so you can see. And what we're going to do is we're going to take and copy this down. I, j, k, u1, u2, u3, v1, v2, v3. And you're going to go along each entry in that row. So the first one was this entry I here. So you're going to pull out, you're going to have this I here, and then you're going to delete the row and the column that had I in it. And you're going to do this for each entry. So now let's go, our next one is J. We have a minus here in the formula. And then I, J, K, U1, U2, U3, V1, V2, V3, J. And then you're going to delete the row that had J in it and the column that had J in it. And the very last step, we're going to go to this entry K here. Now it's a plus. Again, copy everything down. U1, U2, U3, V1, V2, V3, and you'll pull a K out and delete the row and column that contained K. So now you're left with these smaller matrices U2, U3, V2, V3, I minus U1, U3, V1, V3, J plus U1, U2, V1, V2, K. And now the way this works, when you have a 2 by 2, you go multiply the diagonal, and then you're going to subtract multiplying the other way. So this would be U2 V3 minus U3 V2. I minus, so again multiply this way down, U1 V3 minus the other way, U3 V1 J. I'm running out of room, so I'm going to have to go down to the next line, plus diagonal U1 V2, and then minus the other way U2 V1 K. And if you compare these two formulas, you'd see that this formula is the exact same as the formula that we had up above in our definition. It's just a little bit easier to work with determinants because then you don't have to memorize a formula anymore.